Hi, I'm going to show you how to solve a system of equations using elimination and substitution. Remember, when you solve a system of equations, it is the point at which the two equations intersect if you were to graph them on a coordinate plane. So the first thing we're going to do is we're going to solve this equation or this system of equations using elimination. Now, to use elimination, you need the x values of both equations to be inverses of each other, or the y values to be inverses of each other in order for them to cancel out. At this point, neither the x or the y values are inverses, so I am going to change these y values to inverses or opposites of each other by multiplying this first equation by 2. So, if I take 2 times 6x, I get 12x. 2 times 2y is plus 4y. And then 2 times negative 6 is negative 12. So, right now my equation is 2x plus 4y equals negative 12. And this second equation I'm going to copy just as it is. Now, when I add these equations together, you will notice that the 4y and the negative 4y are inverses of each other, and therefore they will just cancel out. And I have 12x plus 3x is 15x, and negative 12 times, I'm sorry, I forgot the negative sign there. Negative 12 plus negative 18 is negative 30. Now I'm going to continue to solve this equation by dividing both sides by 15. Over here it cancels out and x equals negative 2. So once again, I made my y values inverses. They canceled out. I combined the two equations and solved for x. Now I'm going to take that value of x and I'm going to plug it into one of the equations to solve for y. I'm going to plug it right into this second equation. So my second equation is now 3 times negative 2, because I got the negative 2 from here, minus 4y equals negative 18. Negative 6 minus 4y equals negative 18. And I continue to solve by adding 6 to each side. And I get negative 4y equals negative 12. I divide both sides by negative 4. And y equals 3. So the solution for this equation is the point negative 2 and 3. So if I plug the value negative 2, 3 into either of these equations, the negative 2 and for x and the 3 and for y, I would find that both equations are true, and this point is the point at which these two equations would cross on a coordinate plane. Now, to solve using substitution, it makes an equation that looks really messy. However, it is a quick way to find the solution without having to graph both equations. So to do this, I'm going to solve one of the equations for either x or y. Usually you pick the equation that has x or y by itself. So in this case, you can pick either of these equations. I'm just going to take the first one, negative 2x plus y equals 1, and I'm going to solve the equation for y by adding 2x to each side. And I see that y equals 2x plus 1. Now, I'm going to take this value for y and I'm going to plug it in for the second equation. So what I'm going to do is, in place of y, I'm going to put all of this information. So when I rewrite the second equation, I have negative 4x plus, and remember, I'm not writing the letter y, I'm writing this value of y in its place. And now I solve the equation. Negative 4x and 2x is negative 2x plus 1 equals negative 1. I'm going to add 1 to each side. I'm going to subtract 1 from each side. And I'm going to get negative 2x equals negative 2. Divide each side by negative 2. And I have that my x value equals 1. So after I find that my x value equals 1, I'm going to take either equation and plug 1 in for x. So I'll just take the first equation. Negative 2 times 1 plus y equals 1. Remember, down here I found that x is equal to 1. Okay, so all I did was rewrite this equation, but instead of putting an x in, I put that 1 in. So negative 2 times 1 is negative 2 plus y equals 1. I add 2 to each side, and I get y equals 3. So the point at which these two lines would intersect are at the x value of 1, the y value of 3. And if you plugged this value, 1, 3, into either equations, you would see that the equations are true, because this is the point at which these two lines would intersect if graphed on a coordinate plane. I hope this helps you. Have a good day.